let A be an invertible 2 by 2 matrix. Let's obtain a formula for the inverse of A. Our solution goes as follows. We let A be the matrix with 2 rows and 2 columns. We use Gaussian elimination to obtain its inverse. Recall that Gaussian elimination begins with the augmented matrix AI and results with the augmented matrix I, the inverse of A. So let's begin. So that's our A, and that's I, our identity. Let's first get rid of the A21 entry, the 2-1 entry. To do that, we're going to take row 2, and we are going to subtract A2 we're going to subtract A21 over A11, row 1. Why that? I need to get rid, in order to eliminate A21, I need to get rid of A11, which I need to do so by dividing by A11, and I need to multiply by A21. Okay, so we get 0. Next, I take A22 minus A21 over A11 times A12. To subtract here, we're going to write both expressions as fractions with same denominator. So this is the fraction A21, A12 over A11. So I need this first term to have the denominator A11. So we multiply top and bottom by A11. The result, A11, A22 minus A21, A12 over A11. It's a little bit long. Let's make an effort to write it more efficiently. I can replace that expression with the determinant of A, because that is the determinant of A. A11, A22 minus A21, A12. Okay, so here we have 0 minus 1 times A21, A11, which is just negative A21 over A11. And then we have 1 minus 0 times A21 over A11, which is just 1. Okay, next. The next step is to get rid of A12 by using the entry right below it, which is the first non-zero entry of the second row. Now I have mentioned non-zero entry here. Well, it is not non-zero because the determinant of A is different than 0. Because we know that when a matrix is invertible, the determinant of that matrix is not 0. So I would like to make that a 1. So let me multiply the second row by the reciprocal, which is A11 over the determinant of A. Row 2 will be multiplied by A11 over the determinant of A. So 0 times anything is 0. Determinant of A over A11 times its reciprocal gives me 1. I want to multiply negative A21 over A11 times A11 over the determinant of A. There is some cancellation. The A11s cancel. So we're left with the expression negative A21 over determinant of A. Negative A21 over determinant of A. Next, 1 times A11 over determinant of A is just that. A11 over the determinant of A. First row remains unchanged. Okay, our next step, get rid of A12. So for that, I'll take row 1 minus A12 row 2. Row 1 minus A12 row 2. Let's get the result down here. So I get A11 minus 0 times A12, which is just A11. A12 minus A12 times 1, which is A12 minus A12. 0. Mission accomplished. We wanted that. One minus A12 multiplied by this expression right here. Negative A21 over determinant of A. Let's multiply top and bottom of the first term by determinant of A because we want to work with the fraction here. So we get determinant of A over determinant of A. Okay, so let me write determinant of A explicitly because I see some cancellation. This expression becomes plus A12, A21 determinant of A, remember, was A11, A22 minus A21, A12. Notice that there is cancellation. Those two terms cancel. So the result is A11, A22 over determinant A. So A11, A22 over determinant of A. And then 0 minus A12, A11 determinant of A, which is negative. A11, A12 over determinant of A. Second row remains unchanged. Okay, we're almost there. Only thing remaining is to divide multiply the first row by the reciprocal of A11. So let's do that. So multiply row 1 by 1 over A11. So we get A11 divided by over A11 cancels out. 0 times A1 over A11 is still 0. I'm multiplying A11, A22 over determinant of A times 1 over A11. The A11s cancel, so we're left with A22 over determinant of A. Next entry, we're multiplying negative A11, A12 over determinant of A times 1 over A11. So the A11s cancel. We're left with negative A12 over determinant of A. Okay, the second row remains unchanged. So we have 0, 1. Negative A21 over determinant of A, negative A21 over determinant of A, and we have A11 over determinant of A. So that will be our inverse of A inverse. So let me present the final answer. The inverse of A is the matrix we see in the second block, but let's say since the determinant of A is a non-zero constant and it is in the denominator, let me apply a scalar multiplication here to rewrite that matrix as 1 over determinant of A multiplied by the matrix whose first row is A22 negative A12 and second row negative A21 A11. And there is our formula for the inverse of A. Takes a little bit long to obtain, but Gaussian elimination does the job here. So that ends our presentation. That is all.